In August 1945, an American test pilot climbed into the fastest Mustang ever built, nearly 50 miles per hour quicker than the P-51D that escorted bombers to Berlin. Within weeks, he was told this aircraft would never fire a shot. The war it was built to win was already over. That story, in one form or another, is the story of every aircraft on this list. These are among the fastest propeller aircraft ever built. Some flew as prototypes, some rolled off production lines in the hundreds, and every one of them was silenced not by an enemy, but by the calendar. A quick word on the rules. Every aircraft flew before September 2, 1945. Every aircraft flew no confirmed combat sortie. We rank by maximum level flight speed in wartime configuration, and a manufacturer's claim will never outrank an independent military test. Keep that in mind. It changes everything by the time we reach number 4. Which aircraft do you think was the fastest propeller fighter of the entire war? Hold your answer. By the end of this list, you may not be right for the reason you expect. Number 10. Kawasaki Ki-83. Our first aircraft was not killed by bad engineering. It was killed by an entire industry collapsing around it. By late 1944, Japan was desperate. American B-29s were reaching the home islands, and Japan's early war fighters were never designed to intercept large, high-altitude bombers. The Imperial Japanese Army needed something new, something long-range, high-flying, and fast. Mitsubishi handed the project to the team behind the respected Ki-46 reconnaissance aircraft. What they produced was, in the opinion of many aviation historians, the cleanest, most modern-looking Japanese fighter of the entire war, the Kawasaki Ki-83. Twin-engine, single-seat, remarkably aerodynamic. 2 large radials tucked into tight cowlings. An airframe smoother and better proportioned than anything else Japan had produced. Its confirmed top speed in wartime testing was around 438 miles per hour. You will sometimes see 473 quoted for it. There is no solid independent test to back that figure, so we do not use it here. 4 prototypes were built, testing began, and then everything around the aircraft simply stopped working. Japanese factories were being bombed. Aviation fuel was almost impossible to obtain. The industry was disintegrating in real time. Japan surrendered before testing could be completed. 4 airframes existed. The Allies knew so little about the aircraft that they never even bothered to assign it a reporting name. The Ki-83 did not lose in combat. It simply never became a combat aircraft. It died with the industry that was supposed to build it. Number 9. Hawker Fury, land-based prototype. The Ki-8. Number 8. Martin Baker MB-5. Our next aircraft was built by a company you almost certainly know today, but not for airplanes. Almost every ejection seat used in Western military aviation for the past 70 years has come from Martin Baker. Before they built ejection seats, they built one of the most respected experimental fighters of the entire war. And they built exactly one of them, the Martin Baker MB-5, one prototype. First flew in May 1944, powered by a Rolls-Royce Griffon 83 driving contra-rotating propellers. 4 20mm cannons planned, and built around a cockpit that test pilots described as one of the most rational and pilot-friendly they had ever encountered. Top speed reached approximately 460 miles per hour at 20,000 feet. Test pilots loved it. They praised the handling, the performance, and above all, the sensible engineering. Reading their reports today, you would think procurement had lost its mind. But there was a reason. Martin Baker was a small company. It had no capacity to build fighters in numbers. Development was slow. By the time the MB-5 was truly mature, the war was ending, and jet propulsion was becoming the future. It was not rejected because it was bad. It was passed over because it became ready after the war had stopped waiting for it. An excellent fighter that exists as one prototype does not equal a squadron. In 1945, only squadrons mattered. Number 7. Dornier Do 335. The MB-5 never left the prototype stage. Our next aircraft went much further. Pre-production airframes, delivery to conversion units, close enough to smell combat, and still, no confirmed sortie. Most twin-engine fighters carry one engine on each wing. The Dornier Do 335 did something almost no other combat aircraft has ever done. It stacked both engines on the center line of the fuselage, one conventional propeller pulling from the nose, a second engine buried in the rear, driving a pusher propeller behind the tail, 2 Daimler-Benz DB603 engines, far less drag than a normal twin, better handling if one engine failed, and a top speed Germany claimed at approximately 474 miles per hour. That number is a German wartime claim, not an independent Allied test, and historians still debate the exact figure. But there is no serious argument that the Do 335 was, by any standard, blisteringly fast. The pre-production A variant reached a real level of maturity. Airframes were completed. A few reached units where pilots would have transitioned onto the type. Bailing out was such a serious problem, with a pusher propeller directly behind the pilot, that the aircraft was fitted with one of the earliest operational ejection seats in aviation history, along with a system to blow the tail structure clear before ejection. And still, no combat. The rear engine suffered from constant overheating. The systems were complex. Maintenance was brutal. German factories were being bombed. Fuel was scarce. Training was incomplete. The Do 335 came closer to combat than almost anything else on this list. It just could not close the final gap. Germany did not lack for speed. Germany lacked for time. Number 6. North American F-82B Twin Mustang. Our next aircraft was not built because one fighter lacked speed. It was built because no single pilot could stay effective across an ocean of airspace. By 1944, American planners were staring at the Pacific and asking a specific question. When B-29s began their missions over Japan, they would need fighter escort. The problem was not just fuel range, it was human. No single pilot could remain sharp across a mission lasting 8, 10, 12 hours over open ocean. Pilot fatigue was a real operational limit. The answer was the North American F-82B Twin Mustang. 2 fuselages, a shared center wing, a shared tail, a pilot in one fuselage, a co-pilot and navigator in the other. The workload of an enormous mission split between 2 human beings. Common myth says this was 2 P-51s bolted together. It was not. The Twin Mustang was designed from the ground up as an integrated aircraft, with its own structure, its own systems, and a very specific mission. Its top speed reached approximately 482 miles per hour, remarkable for a long-range twin fuselage escort. The XP-82 prototype first flew in June 1945. The war in the Pacific was already closing. In August, the atomic bombs fell. Japan surrendered. The first production F-82Bs arrived at units only after the surrender. The aircraft, built specifically to escort B-29s over Japan, never once escorted a B-29 over Japan. The F-82 did serve. Later variants even flew over Korea, becoming one of the first American aircraft credited with kills in that war. But in the war it had been designed for, it saw nothing. We are halfway down this list, and a real question emerges. Which is the greater waste? A brilliant prototype that was never ordered, or a production aircraft whose mission disappeared before it could be delivered? From here on, the differences between our remaining aircraft will be measured in only a handful of miles per hour. But every one of these last 4 aircraft has a story sharper than the ones before. Number 5. Supermarine Spiteful F-14. To replace the Spitfire, its makers first had to abandon the shape that had made the Spitfire famous. The Spitfire had absorbed mark after mark, more powerful engines, refined airframes, constant upgrades. But there was a limit. The famous elliptical wing that had defined the aircraft since 1936 could not keep buying speed forever. Supermarine needed a new platform, not a new mark of Spitfire, a new aircraft. The Supermarine Spiteful F-14, a fresh airframe, a laminar flow wing designed to slice through the air with less drag, a Rolls-Royce Griffin 69, a 5-blade propeller. Every design choice pointed at one thing: cutting drag and pushing the ceiling higher than the Spitfire could reach. The Spiteful's top speed in wartime configuration reached approximately 483 miles per hour at 21,000 feet. You will see 494 miles per hour associated with the design. That number comes from a post-war variant, not from wartime tests. This was not a lonely prototype. A production order existed. Some airframes were completed well past the prototype stage. So why did it never fight? Development took time. The Spitfire in its late marks was still good enough. The war in Europe ended, and no one was going to fund the industrial rollout of a piston-engine Spitfire successor at the exact moment jets were rewriting the rules. Supermarine had finally built a fighter fast enough to replace the Spitfire. It arrived just as the RAF stopped needing one. But our next aircraft is the one many of you will insist belongs at number 1, and there is a very good reason it does not sit at the top of this list. Number 4. Republic XP-47J. If you have ever seen a list of the fastest piston fighters ever built, you have almost certainly seen this aircraft placed at number 1, and you may already be wondering why, on this list, it is sitting at number 4. The story is worth telling carefully. The Republic XP-47J was not simply a stripped-down P-47D. It was a genuinely reworked airframe, a streamlined cowling, a refined cooling system, a lighter structure, a high-output Pratt & Whitney R2800 engine, turbo supercharger, careful use of exhaust thrust. Republic had taken everything it had learned building the Thunderbolt and pushed it toward pure speed. Republic reported that on a flight commonly associated with August 4, 1944, the XP-47J reached approximately 504 to 505 miles per hour. Sit with that for a moment, because if you accept it, the XP-47J is the fastest aircraft on this list, and it is not even close. But the United States Army Air Forces ran their own independent test, and they could not reproduce Republic's number. Their result came in at approximately 484 miles per hour at a lower altitude, with the engine not producing the power Republic had reported. Now, in fairness, this does not automatically mean Republic lied. Different conditions can produce different results. But when a manufacturer's claim conflicts with an independent military test, we cannot rank the manufacturer's number as equal to the independent one. So the XP-47J sits here at approximately 484 miles per hour, with the famous 504 figure noted for what it is. A well-known claim, but not a settled figure. One prototype, one famous number, and an independent test that quietly put a different figure into the record book. Number 3. De Havilland Hornet. Our next aircraft did something most twin-engine fighters of its era could not. It combined two engines with a frontal area closer to a single-engine fighter than a heavy twin. De Havilland had learned enormous lessons building the Mosquito. Light structure, clean surfaces, ruthless drag reduction. A twin did not have to be bulky. But this was no shrunken Mosquito. The DH-103 Hornet was designed from the outset as a fighter, not adapted from a bomber. The prototype, RR-915, first flew in July 1944. Two Rolls-Royce Merlin engines paired for minimum frontal area, contra-rotating propellers to cancel torque, a slim fuselage, and it was designed with long range from the start because Pacific operations were a core requirement. The prototype's top speed reached approximately 485 miles per hour at 22,000 feet in Boscombe Down trials. Service Hornets ran a bit lower, around 472, but the prototype figure was real and credibly tested. Unlike many aircraft on this list, the Hornet was not a dead end. Production was approved. It entered RAF service. It had a real career. So why does it appear here? Because the Hornet did not reach operational units in time. It entered RAF frontline service after the Pacific War had ended. It was designed to fight over vast Pacific distances and arrived just after the reason for its existence had disappeared. The Hornet proves that an aircraft does not have to fail technically to arrive too late. Sometimes the war simply ends first. Number 2. North American P-51H Mustang. Now we come to the fastest fighter ever to wear the Mustang name, and it never escorted a bomber to Berlin. The Mustang name is one of the most iconic in aviation history. When most people think of the fastest Mustang of the war, they think of the P-51D. Range, speed, escort mission, combat record. Few aircraft in history match its reputation. But North American did not stop with the D. They kept refining. And in the P-51H, they produced something remarkable. The P-51H was not a stripped experimental one-off. It was a production variant, structure redesigned to save weight, fuselage refined, taller tail, Packard-built Merlin with water injection for emergency power. This was not a P-51D with more boost. It was a serious reworking of the Mustang from the inside out. Its top speed reached approximately 487 miles per hour, roughly 50 miles per hour faster than the P-51D that had won the air war over Europe, faster than most operational fighters of any nation during the entire war. And this was not a lone prototype. Approximately 545 P-51H airframes were built, hundreds of production fighters. So why does it appear on this list? Because production began as the Pacific War was closing. The planned frontline deployment ran directly into the surrender of Japan. The fastest production Mustang of the Second World War never fought in the Second World War. The Ki-83 had 4 prototypes. The MB-5 had 1. The XP-47J had 1. The P-51H had hundreds. And even 5 5V5 airframes could not beat the end of a war. Number 1. Republic XP-72, which brings us to number 1. And number 1 on this list is not the aircraft with the most famous top speed claim. It is not the aircraft built in the largest numbers. It is the aircraft that combined a serious flight test program, one of the largest piston engines ever bolted to a fighter, a clear operational mission, and a real production order before the future changed direction and canceled it in midair. The requirement was simple and brutal. Climb fast, reach altitude, Intercept a high-flying bomber, destroy it before it reached its target. Republic already had the Thunderbolt. The XP-47J had pushed the Thunderbolt airframe toward pure speed. The XP-72 was designed to push it further. A dedicated interceptor, a far more powerful engine, a sharper purpose. That engine was the Pratt & Whitney R4360 Wasp Major, a radial with 28 cylinders arranged in 4 rows, capable of over 3,000 horsepower, among the largest and most powerful piston engines ever produced, so massive that it defined the shape of the entire aircraft around it. The Republic XP-72 first flew in February 1944. 2 prototypes were built, one with a conventional propeller, one with contra-rotating propellers. This was not a paper project, not a mock-up. 2 flying aircraft in a real serious test program. Its top speed reached approximately 490 miles per hour at 25,000 feet. So why does the XP-72 sit above the XP-47J on this list, when Republic's claim for the XP-47J was over 500? Because Republic's XP-47J number came from the manufacturer, and the AAF's independent test came in around 484. The XP-72's approximately 490 miles per hour sits with a clearer program, a clearer mission, and a far more serious path toward production. Serious enough that the USAAF did not merely evaluate the aircraft, they placed a production order for 100 airframes. Read that again. 100 production XP-72s were ordered. That is not a curiosity, that is a program. And then the questions the military was asking simply changed. Air superiority was becoming less of a problem. Long-range offensive fighters mattered more than dedicated high-altitude interceptors. Jet propulsion was promising more speed, better climb rates, and a longer future than any piston aircraft could offer. Now, we have to be careful here. This does not mean the XP-72 in service would have dominated the skies or outperformed early jets. That is speculation. What we can say for certain is this: it was fast, it flew, it was ordered, and it never reached combat. 100 aircraft ordered, every single one canceled, because the future had changed before production could even begin. The XP-72 did not lose to another piston fighter. It lost because military aviation had begun asking an entirely different question. Piston power had reached its peak, and the future had already left the propeller behind. Look back across this list. 10 extraordinary aircraft. None of them failed because they lacked speed. They were defeated by timing, by politics, by collapsing industries, by disappearing missions, and by the arrival of the jet engine, proving that the fastest fighter in the world means nothing if it never reaches the front line. So which aircraft would you rank higher? The XP-47J with its disputed 504-mile-per-hour claim? The Do 335 that came so close to combat? Or the twin Mustang whose mission vanished with Japan's surrender? There may never be a perfect answer, because these were aircraft that arrived just a little too late, beaten not by enemy fighters, but by history itself. If you enjoyed this deep dive into the fastest WWII fighters that never saw combat, subscribe to Veen History for more forgotten stories from aviation history.